Alright, so we're talking about adding and subtracting rational numbers. In the previous video, 1.6a, we talked about rational numbers and kind of definitions and writing in simplest form. Now we're going to write them as decimals. So we're going to fast forward here. We've talked about some of this stuff already. Simplifying fractions is just simply rewriting in terms of factors and then canceling factors that are common into a factor of 1. Here, if we're talking about rational numbers and converting to decimals, essentially what we've got is 3 over 10. That's a rational number. It's a rational fraction. 3 over 10 is essentially 3 divided by 10. So you can go the long way. 3 divided by 10 and finally get 0.3. Do the long division of 3 divided by 10. You can get 0.3. You can also write 5/8 as a decimal. If we're taking a look at 5/8, and if we were looking at that as a rational expression, what is that as a decimal? If you go the long way, it's 5 divided by 8, and you do the long division, and you get 0.625, and that would be our decimal. You could also say, well, 5 divided by 8 in the calculator is the same answer there. So that would be the way to kind of convert back and forth between a fraction and a decimal. 1 over 3 is a repeating decimal, because if we take 1 divided by 3, you can do the calculator as well. It's going to be 0, 1.0.3, 0.9. Sorry, the decimal probably should go away. 1 minus 0.9 is 1. We've got another 0, drops down, 0, 10 divided by 3, 3, and we get essentially the same idea, 0.33333, or 0.3 with a bar over it. And that's a repeating decimal. We can have a terminating decimal where the decimal just kind of stops, terminates, ends at one point. We can also have a repeating decimal where the decimal does not stop, doesn't terminate, and it keeps going on forever. That would be a repeating decimal. So that would be the way, two ways to, essentially the same way to get a fraction, a decimal from a fraction. If it doesn't terminate, does not terminate or repeat, a decimal that doesn't terminate or repeat is called irrational. We've got some irrational numbers. Square root of 7 is irrational because it goes on forever and ever and ever. Pi is irrational because it does not have an a. It cannot be rewritten as an a over a b. You can't do it. You can't find 3.1415926, etc. as an a over a b. People have tried, believe it or not. Alright, so let's write these in simplest form and write them as a decimal. Alright, 6 over 60 is, well, let's see. We can say, we're going to just jump to the end here. I got 6 times 1 over 6 times 10. We're going to find a common factor. 6 and 6 are common. 6 divided by 6 is 1, so I got 1 over 10. 1 over 10, if you divide it with the calculator or go 1 divided by 10, you get 0.1. And there's our answer. 60 over 140. Well, the easiest way to say, well, this would be 10 times 6 over 10 times 14. 60 is 10 times 6. 140 is 10 times 14. 10 divided by 10 is 1. So I've got now 6 over 14 is, well, let's see, each one of them have a 2. 2 times 3, 14 is 2 times 7. 2 divided by 2 is 1. I got 3 over 7. 3/7 is, well, let's see, 3 divided by 7 is, this is a, let's see, it is a repeating decimal. Take my word for it. Put a 0 in here. Let's see, I've got 0.4 is 28. I got a 2. Drop down the 0. I got 7 and 20 is 3. 7 and 20 is, oops, sorry, 2. I thought that was wrong. 14. I got 6. 60. 7 into 60. 8. 7 times 8. 56. I've got a 4. I think this is going to be, let's see, you would think it'd be repeating, or sorry, you'd think it'd be keep going on forever, but it's not. You put a 0 down here. 7 into 40. I'm going to extend my page here. 7 into 40. 5. 7 times 5. 35. I got a 5, 0. 7 times 7 times 7 is 49. I've got a 1, I've got a 0, I've got a 1. 7 times 1, 7, 3, but wait a second, I've got 3 is the same as right there, so essentially that would be repeating. My decimal over here, 6 1/40ths, or 3/7 is 0.42857 repeating. And that's a repeating decimal. Anything divided by 7, if it's not a multiple of 7 divided by 7, then it's going to be a repeating decimal, looking something like that. 0.428571.